So for part A, I went ahead and put R of t and D of t into the calculator because it can do that and it's fine. But you really only need R of t for A because it's just asking how much water flows into the pipe during that time period. So you just have to do the integral from 0 to 8 of R of t dt, and the calculator tells us that that is 76.570. And I would put cubic feet there. Okay, everybody good there? Okay, so a lot of times on these types of problems, that's all you're doing in part of it. It's pretty simple, really, since it's calculator active. They're testing to see if you know what to do. It's not very labor intensive to figure it out. Then if we skip down to C, if we want to write an equation for the amount of water in the pipe, then W of t, what would it equal? Right? That's our initial amount because they told us 30 cubic feet of water in the pipe at t equals 0, right? And then we got water coming in and water going out, right? So we're going to add the water going in. What's that going to be? Okay, integral from 0 to t. I'm going to do R of, let's see, capital R of, don't use t in both places like I was about to do. I'm going to use an X right there. So that would be the amount of water that flows into the pipe. You want to do 0 to t. Don't do 0 to 5 or 0 to 8 or 0 to anything else because it's got to be a variable that goes there so that this applies for any point. And then I need to subtract the water that left. What do I do for that? 0 to t of d of, I'm going to use X there as well, like that. Lots of times. Sometimes the initial amount's 0. Sometimes they don't give you an initial amount. There are problems where they only give you like a rate where it's increasing or a rate where it's decreasing. It doesn't have both, but a lot of these have both. Here, so let's go just a little bit. Let's just go ahead and finish this part. Y'all forget to go back and do it. No, I might would. So if I take the derivative of this, what is the derivative of 30? 0. What is the derivative of the integral of R of x? R of t. And then what's the derivative of the integral of d of x? D of t. Right. So if I'm looking at the derivative, to find critical points, I need to know where the derivative equals 0, right? So if R of t minus d of t equals 0, that would mean we're looking for where R of t equals d of t. Right, if I just like moved that d of t over to the other side. How can I find that? Yep, and I've got them graphed right here where I already did this. I'm only looking from 0 to 8, so I don't care about things that happen over here at 9.46. So these two cross, let's make sure that, at 0. So I got t equals 0, and I also have t equals 3.27166. And so I could think really hard about this, like trying to figure out like a sign line or something like that, or what's happening with the rates, but it's got to be endpoints or critical point where this happens. So since I already have this equation set up, I would do W of 0, which I already know is 30. I would do W of 3.27166, and I would do W of 8. And so if I go over here, let me do W of t is 30 plus integral from 0 to t r of x dx minus integral from 0 to t of d of x dx. And then if I do W of 0, W of 3.27166, and W of 8, I get these three values here, so I get 27.965, and I get 48.544 there. I think that's right. Okay, so what would be the answer to this question? 3.27166. So minimum at t equals 3.27166. And this is hours here too. Right, because that WT is the amount. You don't want to plug it into W prime because that would be a rate. Okay. And we want to know when the amount is higher, highest or lowest for those types of problems. We have to do the W prime to get those critical points. That'll give us the critical points. Okay, questions? All right, if you look at some of the others, you're going to see some of the same things that it's looking for. 3 is really, really similar, especially like A. C doesn't ask about, like D asks how many pounds of bananas are on the display at t equals 8. Write yourself an equation for number of bananas, right? Initial amount plus however much is being added minus however much is being taken away for that. So hopefully that will help a little bit, because once you kind of get like the formula of these problems down, I think they're one of the easier types of questions that they usually give. But I think we are definitely not there yet as far as you guys feeling like that. So we need to do some more here. All right, for 8, we have, I'm going to use a dy dx equals x times 1 plus y. So I'm going to multiply by that dx. And so I got dy equals x times 1 plus y dx. I need to get rid of the y. It doesn't matter where the 1 goes, so it's going to be okay to just divide by 1 plus y. There, so now I've got dy over 1 plus y equals x dx. We're okay there, separating. So we're going to integrate both sides. The right side's not that bad to integrate. For the left side, you have to do a u du substitution. Lucas, what would we use for the u? 1 plus y. So du is just going to be dy. So really, this is a pretty easy like u du, because this right here is my du, and this part right here is my u. So when I integrate du over u, I just get natural log, right? So what I'm going to end up with here is natural log of the absolute value of 1 plus y is going to equal, over here, I just have to increase my exponent by 1, divide out front by that 2, and then I'll put a plus c. Okay, everybody okay here? Now, at this point, technically, you have solved, but the problems that involve natural logs, typically, they're going to ask you to solve them for y. They're usually given that way. So, to get rid of a natural log, Lucas, what do I have to do? E to the power on both sides. So, 1 plus y is going to equal. Now, this happens every time, so it is okay. What happens is you got e to the 1/2 x squared times e to the c, but we said that e to the c, we can just change it to a c. So what pretty much happens every time is that capital C gets pulled out front as a coefficient. So you got c e to the 1/2 x squared. You can just do that without really showing any work for it. You're going to see the more problems we do like this, it just happens every time. So they're going to assume you're doing that part in your head. Also, whenever I have that C right there, I don't need the absolute value bars anymore because that C could be positive or negative, which takes care of those absolute value bars. So then I just need to subtract 1 to get that y by itself. So y equals c e to the 1/2 x squared minus 1. I believe they gave it like this, c e to the x squared over 2 minus 1, but that's equivalent because if I just half of x squared, it's just, it could also be written x squared over 2. Okay, questions? All right, let's look at our notes for today. And that seems like a thick packet, but it also has your homework attached to the back of it. So, like the last 4 questions are the homework problems that we'll do with that. So, all right, so today we're pretty much doing what we were doing yesterday, but we're taking it a step further. So yesterday we were just finding a general solution that involved a C. What we're doing now is we are being given some sort of initial condition. So we know at least 1 point on the original graph. And if we know 1 point on the original graph, then we can find the exact solution. Because all of these solutions that we found yesterday, all the ones that we see over here like this, with a C right there, it's really an infinite amount of solutions, right? Because that C could be 1, or it could be 2, or it could be 7, or it could be negative 44. So you really have like an infinite number. But in most situations, when you start using differential equations in real life, there's only one that actually works, right? Because you know a constraint for whatever you're looking at, and there's only one that actually works. So today we're not really looking at applications of this very much. We will look at those tomorrow, and there's a lot of really cool things that happen with this. Today we're mostly looking at just how to do this. Tomorrow we'll look at where it applies. So the first part of all of these problems is exactly what you were doing yesterday. You need to separate your variables and integrate. So in this case, this one's a little hard to separate. We've got dy over dx equals y squared minus xy squared. Any ideas on separating that? I'm going to do this. I'm going to write it y squared minus x squared y squared. So I could multiply by dx. I'm going to have to do that every time, pretty much. So dy equals y squared minus x squared y squared dx. What do you think? That's exactly what we need to do. So we're going to have y squared times 1 minus x squared dx. And now, what can I do with that y squared, Lexi? Divide by y squared. And so I've got, I'm going to write that as y to the negative 2 dy. It will be easier to integrate that way. And over here, I've got 1 minus x squared dx.
Is the 1 just to hold the place of the negative?
Yes, because if you were going to multiply this back together, when you pull that y squared out, something has to be there, because when you multiply it back, you got to do y squared times 1, which gives you that y squared, and the y squared times x squared, which gives you the x squared y squared. If you don't have that 1, you lose that part, and it's not equivalent anymore. Okay, we good here? So once we get here, we're ready to integrate. Neither one of these are terrible to integrate because they're just power rule integration. So increase your exponent by 1, that'll give you a negative 1. Divide out front by the negative 1, that'll give you a negative. Oh wait, I don't know why I'm writing dy, it's gone now. And then over here, when I integrate 1, what do I get? 1x. And then over here, I'm going to increase that exponent by 1. That'll give me x to the third. I need to divide out front by 1/3. And I need to put a plus c. So that's pretty much what we were doing yesterday, right? Not a lot of difference other than the equation's a little bit different. But if you look at your answer choices, do you see any C's? You do not. You also should notice that all of your answer choices are solved for y. So at this point, you have options on what you can do. You can either solve it for y first, or you can plug in your initial condition and find c first. It doesn't really matter which one you do first. There's some equations where I think it's easier to do it one way than the other, but not always. I think on this one, I would like to go ahead and find c. So I've got the point y of 3 equals 1. So I got the point 3, 1. So I'm going to plug those values in. 3 is my x, 1 is my y. All right. I'm also going to rewrite negative y to the negative 1. I'm going to write it as negative 1 over y. So I've got negative 1 over the y is 1. And then I've got 3 minus 1/3 times 3 cubed plus c. Okay, so I got negative 1 equals 3 minus 3 to the third is 27, but then I multiply it by 1/3, which gives me 9. So negative 1 equals negative 6 plus c. I need to add the 6, and so c equals 5. So that c could be plugged back in up here for the c here. And I'm going to write it as negative 1 over y equals x minus 1/3 x cubed plus 5. Okay, does it look like any of our answers here? Still not an answer, right? Like we still have some work to do. So you're trying to solve this for the y. Are we going to be able to solve for y when y is in the bottom? Certainly not. So we are going to multiply by y on both sides. So we got negative 1 equals x minus 1/3 x to the third plus 5 times y. All right, what do we need to do now? Divide this, x minus 1/3 x to the third plus 5. All right, so now I've got negative 1 over x minus 1/3 x to the third plus 5 equals y. All right, I've got it. Solve for y. Is it an answer choice? There's a couple of them I don't think are even close. C and D don't really look like this at all. C has an E added in there, which definitely didn't show up. D has an E. C is not a fraction. It's got a 1/3 power. I don't think those are it. A and B seem like the most likely possibilities. Which one do you feel like is probably right? B looks the most like this. What can we do to what we have to turn it into B? What? If we multiply top and bottom by 3, right there, if I multiply top by 3 and the whole bottom by 3, it'll get rid of that 1/3 right there, which is what they have done. And so when I do that, I will get negative 3 over 3x. 3 times 1/3 is just 1, so you just get an x cubed right there, plus 15 equals your y, and there B is our answer. These problems are long, but their steps kind of remain the same every time. Separate, integrate, plug in, find the C, solve for y. Mm-hmm. There's no plus sign in between. So like where if it had been like x plus y squared, we would have to square double square. But since they are both just being multiplied, what you've got right there is xy times xy is what they're telling you, which is just going to be x squared y squared. Yeah. If it was x plus y squared, we wouldn't be able to do it. You wouldn't be able to separate. All right, questions? All right, moving on. Let's do a free response question. So this is the type of free response question that you used to would have seen. I don't think you're going to see A on the exam anymore because they're not going to give you that there for the slope field. In fact, because of that, let's skip the slope field because I feel pretty confident they can't ask you that anymore based on how they've changed the test. So dy over dx is y minus 1 over x. I'm going to write that down right here. Dy over dx equals y minus 1 over x. Okay, so let y equals f of x be the particular solution to the given differential equation with the initial condition f of 3 equals 2. Write an equation for the line tangent to the graph of y equals f of x at x equals 3. Use the equation to approximate the value of 3.3. This question is not asking you to solve the differential equation. You have enough information to do it, but it's not asking you to do it here. What is it asking you to come up with? Okay, the y equals equation of what? The tangent line, right? So you're looking for that line tangent. What do we need for a tangent line? This is one of those things that's old, but we were pretty good at it at the time. We need a point, which would be our f of 3 equals 2 that is given. So that's the point 3, 2. We need the slope. And how do we find a slope? F prime of 3, but they don't give us F prime. But they do give us dy dx, which is the derivative as well, right? So we can do dy dx such that xy equals 3, 2. And that is going to be 2 minus 1 over 3, which is going to be 1/3. That's our slope. There. So for our tangent line, we're just going to say y is 1/3 x minus 3 plus 2. And then they did ask us to approximate using that line. So we're just going to do f of 3.3 is approximately 1/3 of 3.3 minus 3 plus 2. And this is a calculator inactive question, and I would leave it there. I wouldn't simplify. Because you got to do 1/3 of 0.3, which I feel like we're going to mess up. So I would just stop. Okay, questions? All right, part C is where they want you to actually solve the differential equation. So we got dy over dx equals y minus 1 over x. Now, this is how they word it on a free response question. If you see a differential equation free response question, they say find the particular solution y equals f of x to the given differential equation with the initial condition f of 3 equals 2. This part right here, y equals f of x, that is them telling you that you have to solve the equation for y. So you can't just stop once you have found the solution. You have to solve that equation for y. There. So you are going to begin, like we have all the others, you're going to separate. So you're going to multiply by dx. So I got dy equals y minus 1 over x dx. What do I need to do? That's going to put, if I multiply by x, it's going to put the x over there with my dy. Say it again, Evan. Yes. What I would do is I would just multiply. Pen's messing up here. I would just like multiply by 1 over y minus 1 right here. Like that. So that's going to give us 1 over y minus 1 dy equals, that x is in the bottom, so it's 1 over x dx. Or if you wanted to write that dy over y minus 1 equals dx over x minus 1 dx over x, that would be fine also. Okay, everybody good here? All right, what do we need to do next? Integrate. We're ready to integrate. Now, technically, you are doing a u-du substitution here, but it is a very tiny u-du substitution because you got u is y minus 1, so du is dy. So this right here is your du, and this right here is your u. There were no special numbers we had to like add in or anything. So when I integrate 1 over u du, what am I going to get? Natural log. So we'll get natural log, absolute value. I'm going to go ahead and put y minus 1 back in. I'm not going to do the u. And what is the integral of 1 over x dx? Plus c. Yeah. All right. At this point, you can either find the C, or you could find the, you can either find the C, or you could solve for Y. I'm somewhat inclined to solve for Y on this one, but I'll plug my 2, it's going to be 0. Yeah. Because that's going to give us a, I think in this particular case, it might be a little bit easier to solve for Y first, then plug in. The main reason being that a lot of those natural logs are going to like go away. Makes it easier to plug the number in. Although you could do it by plugging 3, 2 in right now. So for this one, these last 2 steps are interchangeable. Sometimes you can solve for Y first. Sometimes you can plug in and find your C first. Go with what, it usually should be possible to do it either way. Just go with whatever feels easiest to you. I really don't like having to solve with all those natural logs. I would do e to the power on both sides. Now over here, this will cancel. I will have y minus 1. Over here, they're also going to cancel, but what happens with that plus c right there? It is like, yeah, it's going to be like e natural log of the absolute value of x times e to the c, which, as you said, we can just call that capital C. So I would go ahead and write it like this, c, really just cx, because here that e and the natural log cancel, the c sort of comes out here as the coefficient. Absolute value bars are not necessary right now because your absolute value bars are not necessary anymore because you got that c that could be positive or negative that takes care of it. And so now we just need to add 1, so we get cx plus 1. So we already have this one solved for y. We now just need to plug in that 3 and that 2 to find our c value. So this is our point 3, 2. This is our x coordinate. This is our y coordinate. So we've got 2 equals c times 3 plus 1. So 2 equals 3c plus 1. I'll subtract 1 and get 1 equals 3c. Divide by 3, and c equals 1/3. So that gets plugged back in up here. Y equals 1/3 x plus 1. Okay, questions? Okay, let's look at this one. This one is a weird problem. The general solution to the differential equation dy dx equals x over y is y equals plus or minus the square root of x squared plus c. Let y equals f of x be the particular solution to the differential equation with the initial condition f of negative 2 equals negative square root of 2. Which of the following is an expression for f of x and the domain for which the solution is valid? So this gives you the solution. Like, you don't have to solve it. So if you did solve this differential equation, you would get y equals plus or minus the square root of x squared plus c. Right? And so they ask us to solve here to get that value, and then we also have to talk about the domain for that problem. So if we want to solve here, we got the point negative 2, negative square root of 2. And so I would put a negative square root of 2 here equals plus or minus the square root of negative 2 squared plus c. Now, in this case, if I'm getting a -2 right here, the plus or minus, I've got to choose one. Which one is it going to have to be for these two things to be equal? It's got to be the minus, right? I got to choose the minus right here, because if it's positive, there's no way I'm going to get a negative square root of 2. There's nothing that would work there for that. So I'm going to have negative square root of 2 equals negative square root of 4 plus c. I could square both sides, which will get rid of the negative and get rid of the square root. So I've got 2 equals 4 plus c. And I'm going to subtract that 4. And I got -2 equals my c. So my equation is going to be y equals, I want to choose the minus. I can't choose the positive because I can't get a negative square root of 2 if I choose the positive. So negative square root of x squared minus 2. So this just narrows this down to a couple, right? There's 2 answer choices with that equation. So it's not B and it's not D. It's either A or C. So, in this case, my options are either absolute value of x is greater than square root of 2, or it's x is less than negative square root of 2. Both of these actually work for the equation. However, for this, let me see. I'm pretty sure it's A, but I'm forgetting no reason. Hold on just a second. That's this one. Yeah. Let me consult my notes here. I don't think it's right. I know why it would be C, but I think it's, this is AP class, right? Hold on. I think my notes are wrong. The last 4 problems are your homework if you want to do one of those problems while I consult my sources here. Sorry. You can skip the slope field, yeah. On the
But example 4 is not homework.
right, you don't have to do example 4. And we'll probably not have time for example 4, so y'all just go ahead and work on the ones where it starts to say homework. You can skip the, you don't have to graph the slope field, do the rest of that problem, but you don't have to graph the slope field. let me explain this real quick and I'll let y'all pick back up. So, for this, the underneath the square root, whatever you have has to be greater than or equal to 0, right? So x squared minus 2 has to be greater than or equal to 0, which means x squared has to be greater than or equal to 2. And then if you square root both sides, you really can't do a plus or minus with the absolute value. This gives you, like, the absolute value of x has to be greater than or equal to 2. However, I'm sorry, square root of 2. However, we have an initial condition right here, because this is like, this means either x is greater than or equal to square root of 2, or x is less than or equal to negative square root of 2 is what it means. It's not, both of those things can't happen at the same time. We have the point negative 2, right? That's our initial condition. So we have to choose one side of this. You could also think about, like, when you're thinking about x squared being less than 2, like, you got square root of 2 and negative square root of 2. You're talking about, it could either be the numbers bigger than square root of 2 or less than square root of negative 2. But whenever you're doing a differential equation like this, just like we had to choose the plus or minus, you've got to choose one of those sides. Because your x value here is negative 2, it has to be A. It has to be the ones where this is less than negative 2. So whenever you see a problem like this, you've got to make choices whenever there's like a plus or minus. So you wouldn't really see one where you've got the absolute value as part of your answer. There. We didn't get to 4, but that's okay. I think you should still be able to do everything okay. You can skip the slope field. 3 is very similar to the other 3. I think you should be hopefully okay on